Economists plot cost curves with quantity on the horizontal axis and dollars on the vertical axis. We're going to talk about four curves: marginal cost curve, average total cost curve, average variable cost curve, and the average fixed cost curve. Let's start with average fixed cost. It's probably the simplest. Whenever quantity goes up, that will make the average fixed cost go down. The reason is simple. Average fixed cost is fixed cost over output. As output rises, the denominator will increase, but fixed cost is fixed. It doesn't stay. It remains constant. I'll put a little equal sign there. When the numerator remains constant and the denominator increases, that means that the ratio, or the average, must fall. So whenever the firm increases output, average fixed cost will decrease. Next, let's talk about average total cost. Average total cost will be quantity, dollars. Average total cost will be a U-shaped curve. Moreover, we know that the marginal cost curve will intersect, let's make marginal cost in blue, marginal cost will intersect the average total cost at the minimum average total cost, make it purple, where they intersect. The reason for this is pretty simple. A little dotted line here. To the left of the minimum point, marginal cost is less than average total cost. Whenever marginal cost is less than average total cost, an increase in output will make average total cost go down. The reason is not economics, it's simply math. It happens when you take a test. Suppose you've got an average of 80 after taking 3 tests, and you take the 4th test. The 4th test is your marginal score. If the 4th test is a 70, and you had an 80 going into it, that marginal score is going to pull your average down. Similarly, if you've taken 3 tests and your average is 80, and you score a 90 on the 4th test, that higher score on the marginal test, or the 4th test, is going to pull your average up. So whenever marginal cost is below average total cost, an increase in output will make average total cost decrease, and vice versa. Now let's look at what happens on the other side of the dotted line. Here, marginal cost is greater than average total cost. Whenever marginal cost is greater than average total cost, an increase in output will cause average total cost to increase. It's got to happen. Again, it's math, not economics. Next will be the average variable cost curve. The average variable cost can have 2 different shapes. The one we have here is a nice straight line. It always goes up. So quantity goes up. Yeah, let's make that a little bit nicer. Quantity goes up, makes average variable cost increase. That happens when marginal cost is always above average variable cost. Marginal cost and average variable cost have this average marginal relationship, just like your last test score and your previous average, just like marginal cost and average total cost do. So if marginal cost is always above average variable cost, the average variable cost curve will always have a positive slope. The other option, though, is for us to have something that looks like this. Average variable cost is a U-shaped curve, and marginal cost intersects the average at the minimum average variable cost. Again, as long as marginal cost is less than average variable cost, the average variable cost curve has a negative slope. When marginal cost is greater than average variable cost, the average variable cost curve has a positive slope. You put those 2 things together, it guarantees that marginal cost intersects the average variable cost curve at the minimum point on the average variable cost curve. Finally, marginal cost. Marginal cost can have, one of two slopes. It can always increase. Marginal cost always increases when an increase in L, or the variable input, always makes marginal product of L go down. Suppose the firm begins to experience diminishing or decreasing marginal product as soon as it starts hiring the second worker. In that case, as L increases, marginal product goes down. That guarantees that as quantity goes up, then marginal cost goes up. When marginal product falls, marginal cost rises, and vice versa. The other option is to have something that looks like this. We got quantity, we got dollars, here's marginal cost. Marginal cost can be a U-shaped curve. That occurs when, for a while, as L goes up, marginal product of L increases because of cooperation and specialization. And then the firm begins to experience diminished returns. As L goes up, that makes marginal product of L go down. Once the firm begins to experience diminished returns or diminished marginal product, then an increase in output will make marginal costs start to rise. So we'll get that positive slope on the marginal cost curve.